Hello everyone, it's Ms. Graham. We're starting our unit on probability today. So we're going to begin by talking about some vocabulary that we're going to use in our probability unit. First, let's define the word probability. So when I talk about probability, I'm talking about the likeliness of something happening. So it's a number between 0 and 1, so it could be a decimal or a fraction, and we can convert that into a percentage. So for example, if I'm flipping a coin, I have 1 heads out of 2 sides, so that would convert to 0.5. And that would be 50%. So that's a little bit about how probability would work, and we're going to go into that more detail in a couple of days. An experiment is a process or an action that has observable results. So for example, in probability, we might be drawing an M&M from a bag of M&Ms. That would be the experiment. Or flipping a coin would be an experiment. Or rolling a die, that would be an experiment. The outcomes are the results from the experiment. So if I flipped a coin, the outcomes would be either heads or tails. Or it would be all the M&Ms in the bag, which are possible outcomes. The sample space in probability is the set or the list of all possible outcomes. So if I'm flipping a coin, the sample space would be either heads or tails. If I'm rolling a die, then the sample space would be 1, 2, 3, 4, 5, 6, if there are 6 sides to the die. It's also known as the universal set, but we'll talk about what sets mean in a minute. For example, a sample space for M&Ms would be listing out all of the types and the colors of M&Ms. So you can have plain red or peanut red, plain yellow, peanut yellow. Listing all of the possible M&Ms in the bag or in the dish would be the sample space. So a set, when we talk about a set, that's a list of collections or items. So for example, if I'm going to list the set of numbers on a 6-sided die, then my set would be 1, 2, 3, 4, 5, 6. And they usually have these little brackets around them just to let you know that that is a set. It could be numbers, it could be shapes, it could be names. A set is just a list of items. Elements are what's inside of the set, so the names in the set or the shapes in the set or the numbers in the set. Each one of those are elements. So for example, if you're talking about cards, which if you do not know how many cards are in a deck or how many of each card is in a deck, then your homework for today is to play cards with someone. You need to know how many kings, how many aces, how many reds, how many spades. Those are going to come up pretty often in probability. So for example, the experiment would be picking a card from a deck of cards. So it's the action that you are doing. The sample space is the list of all of the cards in the deck, beginning from A's down to 2, however you want to write those. And then the element is the item within the set. So a jack of hearts or queen of hearts or 2 of spades, those would be the elements. If you're talking about dice, then the experiment would be rolling the dice because that's the actual action that you're doing. The sample space would be all of the possible numbers. So if you're rolling 1 die, it would be 1 through 6. If you're rolling 2 die, it would be written as 1 through 6, but you would have to think about you have 2 different die that you're rolling. And then number 5 is an element within the set. If you have a spinner, so if you think about a board game where you spin and you land on something, the experiment would be actually spinning the spinner. The sample space is the colors on the spinner, so yellow, red, blue, green. and the element would be the color red, which is within the sample space. So in probability, we talk about set notation. We'll go into that a little bit more tomorrow, but within a set, you have subsets. Is a list or collection of items all contained within another set. So if I have a set that's the sides on a six-sided die, then a subset of that could be the odds in that set. So it could be 1, 3, 5. That would be a subset of the original set of the six sides of the die. It's denoted by this symbol right here. It's kind of like a sideways C. And what this means is if all the elements of A are also in B. So A would go inside of B. So a subset is just part of a set. An empty set has no elements. So if I'm talking about the numbers above 7 on a six-sided die, it would have no elements. So we just put the 0 with the slash through it. It's not actually 0 because 0 could be a number. So we just put the slash through it to note that it's a null set or it has no elements. Union is this symbol right here, which actually looks like a U, so that makes sense. It means to unite, so you're going to unite two different sets together, everything in both sets all together. So union is putting set A and set B together. We'll talk about that in more detail tomorrow. Intersection is this shape. I say it looks like an N, like intersection, in. It's only what the sets share with each other or what they have in common. So if you're looking at a six-sided die and another six-sided die, they would have all of the same numbers, so that would be the intersection, would be all of their numbers. And we'll talk about more of that when we talk about Venn diagrams. A complement is shown two different ways. You could see this little apostrophe on the set number, or you could see this little line above the set letter number. So we usually use the apostrophe to show a complement. Complement is everything outside of that set. So if we're talking about the numbers on the die, on a six-sided die, 1 through 6, then everything outside of that deck or out of that number set would be every number above 7 or below 1. So a complement is just everything outside. And sometimes we show Venn diagrams to collect our data and to show it in different ways as a visual. So a Venn diagram is a picture that illustrates the relationship between two or more sets. And you might have seen these before in other classes. We're going to use these tomorrow when we talk about the relationship between two or more sets.